Yeah, I'm the CTO here at Vaayu. Our vision is to decelerate climate change, and that we do that by empowering retailers to manage and especially cut their carbon emissions. And as you can imagine, this is a very data-driven business. So we kind of have some special needs there, and that is why we specifically employ programmable systems to let certain, have a more wide range of users use technology in more creative ways. It's a very vague way of describing things. But basically, we apply those especially in internal tools where, we use a domain-specific language to enable a broad range of internal users to more effectively program systems. And those users, what a domain-specific language enables us to do is that the users don't need to be programmers per se, but they might just have a very simple grammar that they need to know within this domain-specific language that they need to learn to then be able to customize the way that the system works and kind of get creative with these systems. Specifically, we're using Tickle to do this, and I'll dive into that in a bit more depth. And this talk is specifically about how we apply Tickle in a Go host environment. So we're using Golang for many of our backend services. So specifically, just a quick overview over what I mean when I say domain-specific language. In general, that's just like a specialized computer language dedicated to one specific domain. It can even be an kind of embedded language in another language. That's more what we do, right? We kind of customize Tickle, so to say, to an extent where it might not be recognizable as being Tickle, but instead be highly specialized for the specific domain. I'd say, in general, domain-specific languages aren't a good solution for all problems, let's say. It's requires kind of quite a specific setup or a specific set of circumstances for it to make sense. So for one, you need to be able to, the problem needs to look like this, that you have kind of a type of program that needs to be written in many, many different ways and by many, many different people, where these many different people might not necessarily be programmers, but might be somewhat tech savvy and might have used like a scripting language before, so kind of have the necessary background to get into to learn a grammar of a programming language. And I think in general it's quite important that, right, there are different ways of abstracting such things. You could use a user interface for these types of internal tools. You can use like visual programming tools as well. You could even use, in many cases, where a domain-specific language might be used, you could even just use a configuration language like YAML instead of going for a full-blown TCL setup, which is fully programmable. And I think the point at which a proper domain-specific language starts making sense is where you really need this procedural nature. You have maybe a high variety of use cases where you can't necessarily predict from the get-go what all the use cases will be, but you really want your users to get creative with it. And of course, another use case for domain-specific languages is where simply the complexity of the systems that need to be created using the language can't easily be encapsulated, or is so high that it can't easily be encapsulated in a simple configuration language. So we're specifically using Tickle for a few reasons. One is that it's battle tested. It was initially released in 1988, I think, and has kind of had a steady core user base since then. It has been becoming a bit more popular in recent years for some reason. I don't know why exactly, like since 2014 or something, you see pretty big updrift in the Google Trends analysis. But yeah, and Tickle offers one specific feature which makes it uniquely suited to be embedded, to be easily embedded into a host system, which is that it has a feature called a safe interpreter, and basically you can create an isolated, so to say, sandbox environment in which you can safely evaluate foreign scripts. And if you have a very broad user base of your domain-specific language, then this might be desirable. You might not want for everyone to be able to open files on your host system and yeah, screw with things like that. So another advantage is that Tickle has a very, very simple grammar, so that makes it uniquely suited to, yeah, really customize or create abstractions that might in other languages not be possible, because yeah, you can just get a bit more creative in terms of the abstractions that you create. And of course, Tickle does offer quite a decent performance as well, which is important to mention as well. Tickle has a few unique features, or yeah, a few features that make it kind of especially suited for domain-specific languages. Besides, like in its core language itself, besides the ones that I listed before. And I'm just going to touch upon 2 points, and then I'm going to dive into a bit the specifics of integrating Tickle into a Go host environment. So here we can see kind of the normal way of using Tickle, and I won't dive that much into what the grammar of Tickle looks like, but basically these square brackets mean that you're executing a different command inside, and basically Tickle has a very simple grammar, as mentioned before. You usually just say command space and then space separated parameters one by one, which you pass. So for setting a variable, so here we're setting y, you're saying set y is 12, and here you're saying set x is, and then you're evaluating here this expression here, which for Tickle there has its own kind of yes, little sub language, then a mini language in it, as they call it, which is the expression language, which then allows yeah, simple math operations, simple arithmetic operations to be done. So yeah, here we have like x being set to 1 times 2, basically. And to explain one of these features which is called kind of unknown procedures, you can basically override the behavior that Tickle, or yeah, the procedure that is being called when Tickle doesn't know a command. And using that very simple mechanism, you can create new grammar and can get quite creative about yeah, kind of the syntax you want to implement in a domain-specific language. So here, down here in the second section, this is an example of what can be implemented very easily using the unknown mechanism. So you're just saying, well, I believe for my specific domain, an assignment operator, a proper assignment operator might be easier for people to pick up. So I'm going to say, well, assigning a language, I'm now going to implement assigning a variable. For that, I'm going to implement a dedicated operator. And yeah, same, you can do that as well for expression syntax. So you can say, yeah, when basically the way that the unknown mechanism works here in the first line is that Tickle encounters this y and knows or sees that it doesn't have a command called y. So basically it goes into the unknown procedure, and then the unknown procedure goes and sees, oh, I have a command being executed with 3 variables in the end, being y, the operator, and 42. And then it checks, is there this special assignment operator used? And if that is the case, it then executes kind of the procedure for this special assignment syntax. And the same logic goes for this 1 times 2, where I can basically say, well, if if I have 3 arguments that I'm passing to an unknown command, and the middle one is a math operator. So it's like multiplication or addition or whatever. Then I'm going to execute the an expression, execute the whole command as an expression instead. So that's just a simple example of how this unknown mechanism can be used. Another very nice feature of Tickle that is kind of special is that you can you have a special suite of commands to introspect scripts. So you can say here, for an example, version here is a special procedure that goes and reads the whole context that is currently being executed. So reads the whole kind of set output and output, well, small spelling error there, pieces, and then can kind of do arbitrary modifications on that. Can say, I don't know, within the context of that script, you might want to define unknown as something else if version is 1. And that is kind of a very easy way to, for an example, in the example here, basically I used it to create different versions of a language so that you can have different versions of your domain-specific languages and have different behaviors there. And Tickle makes that very easy. So let's dive into a bit how Tickle can then be embedded into Go, because it requires, a bit of some special techniques, let's say, to embed it. So first of all, Tickle is a C library, or can be used as a C library, or provides a C API, let's say, to be accurate. And that, of course, makes it fairly straightforward to integrate in any Go program using C Go. Now, that comes with a few downsides, of course, but I will just kind of explain how we use it and how we integrate Tickle in our environment there. So I've simplified all the code examples to cut out a lot of the kind of error handling and noise to focus on the important parts, just to say. And basically, first of all, to use Tickle in Go as an embedded language within Go, you will want to kind of create an interpreter, and then you want to create a child interpreter with the isSafe flag. And basically, what that does is, well, it creates a safe sandbox interpreter, this sinterp here, that so that any script run within that can't access the file system API or anything like that. Another important piece is that, of course, to use something like Tickle C API, you will want to lock your OS thread. Otherwise, you will run into very weird things with your Go routine jumping from or your Go routine execution environment jumping from one thread to the other, and then suddenly Tickle will try to access memory that is actually not accessible to it. And there's some basic cleanup procedure there as well, of course, in unlocking the OS thread and deleting the interpreter. Now, this is pretty simple and easy and works well if you're just executing a one-off script within your Go server. You might be executing a script once a minute or something that takes a while, that does some kind of cron job or whatever. But we have a bit of a different use case, or a few different use cases, where we want to execute Tickle scripts at a pretty high rate and in many different Go routines, which then creates the problem is that if you execute this the script right here in every single Go routine, say when a request is run to you, given to your HTTP server, this will really blow up your memory usage. And since Go will then have to allocate and create a operating system thread for every single Go routine that uses a Tickle script. So to kind of counteract that and to help with that, what we're doing there is we basically create a pool of Tickle interpreters, and then so we just have a dedicated pool size, say like 20 Tickle interpreters that we spawn per per instance. And then basically in Go, you can pretty easily manage a pool like that using channels. So pool here is a channel, and then we're just looping, pushing new things into the pool channel as long as it's not full, kind of creating new interpreters here and pushing that into the pool. And those can then be used from anywhere. You can just pull one interpreter out of the pool and then start using it. However, for that to work, you need another piece, because since I said in the beginning, right, if you create a Tickle interpreter, you have to lock it to an operating system thread. So to counteract that, basically what we do is we then create kind of have a bit of a wrapper around each interpreter that then the client can talk to like this. So you first take an interpreter out of the pool like this, then you say, well, defer, once I'm done, I will place the interpreter back into the pool, pretty straightforward. And then instead of directly calling anything under interpreter, there is a channel called command, where we then send here I just, in the pseudocode, I just created a sort of defined a struct called eval, and basically that is a signals to the interpreter that it should evaluate this specific expression. And then after that, we have another channel which communicates the results. And then we wait until we get a result. And within result, maybe you have an error property and a success property or something, where you then get the output of that Tickle script. And with this, it is fairly easy to scale up your Tickle usage and have a high rate of evaluations within a Go environment. It's fairly easy. And basically one additional thing that we do as well is that if we go back here initially, usually what you would do then for each new instance or for each new evaluation, you might want a clear sandbox and a new fresh sandbox. So for everything, every time we would create a new child interpreter, every time an eval call is made, so that we make sure that we have no interference from one script to the other. If, however, you can accept kind of the small risk of one script bleeding some kind of state into another or something like that, and you kind of trust your user enough, or there is no attack vector for one script to kind of get some kind of state from the other or something like that, then of course it is recommendable to reuse the interpreter instances, because that speeds up everything quite a lot, because you're not creating a Tickle interpreter every time a script is evaluated. And lastly, one important feature of Tickle when used as in an embedded, or when used in a host environment, is defining commands, custom commands within which can then be used within the Tickle scripts. So this is a bit tricky because Go has kind of some peculiarities, let's say. So I'll just quickly run through kind of how we achieve this. Basically, the C API of Tickle takes a callback function when you define a procedure. So you call DCL define procedure, you pass it a name of your procedure, and then some other parameters, and you pass it a callback function, which is a C function that should be called whenever that procedure is called. And callback functions C callback functions can't simply be passed to or function pointers can't be passed simply to a CGO function. So instead, we have to work around that a bit. And the way that we do this is in Tickle, there's a pretty easy way to do it. The way that the Tickle API is designed, basically we define a generic call command proc Go function. This is exported here, so it's available to CGO. It then simply gets a few arguments, it gets all the arguments to the procedure, the first argument always being the name of the procedure. And that is then kind of how you can recognize your which procedure has been called. So for every single custom defined Go TCL procedure, this one function will be called, and it'll go through the switch case statement. And here we're defining kind of a procedure called goproc, a custom procedure, and it, I don't know, simply returns a string which says, here's a result, and then sets this using the TCLC API. And then the rest is relatively straightforward. So you then have to define a C function within your Go header, so to say, so that is compiled. And that C function, so here I'm calling it call command proc underscore cgo, that then calls out to our previous Go function called call cmd proc, which is this function, right, which we saw before. And then this, what all we're doing then when defining a TCL procedure is we're then registering this C function, and that works like this. So that is again in Go. We're basically saying down here, TCL create command, passing the safe interpreter, passing the name of the procedure. Here you can see we assigned a C string called goproc, and then as a command, which is then the function being called, we pass this generic call command proc underscore go cgo function pointer, which is this function, which then calls this function here. So we then end up in the switch case statement. So that's kind of a simple way to get around the restriction that cgo has, where you can't simply pass a Go function pointer to a C function. Yeah, I mean, that is pretty much my presentation. We recently just raised a big seed round with Atomico, which we're super excited about, and obviously we're really looking for smart engineers to expand the team. And yeah, so thank you for listening in. And